How does the muscle on your body influence what is happening in your brain? I'm Dr. Austin Perlmutter, and one of the most common questions that I get concerns the role of our muscle, what we can do to build healthy muscle, and how it relates to our brain health. Your muscle, and in particular your skeletal muscle, we now understand influences so many different aspects of what is happening in your body. It provides structural support, it allows you to move, it influences your temperature regulation, it facilitates breathing. But we are now learning that your skeletal muscle participates in signaling across the body and especially into the brain. The pathways that link your muscle to your brain include effects on your metabolism, your immune system, and the rewiring of your brain, a process called neuroplasticity. And that means that alterations in these signals as a function of your muscle health can influence your brain health. That means that muscle changes can influence things like premature brain aging, mood issues, and even risk for dementia and behavioral challenges. In this conversation, we're going to be exploring the most important pathways linking skeletal muscle to brain health and practical tips on how to build and maintain healthy muscle, including the key science around diet, exercise, and the role of supplements. Again, this is a very important conversation. It's one that I hear about from so many people wanting to learn about the science. So we're really going to distill down the most important science, and in particular, the neuroscience of how our muscle influences our brain health. Again, I'm Dr. Austin Perlmutter. If you're interested in this type of information, if you want to learn about how to influence your brain health for the better, make sure to subscribe, follow along. You'll get all sorts of access to brand new content around how to improve your brain. This particular video, this particular podcast is based around a free muscle guide, which I wrote, which you can download for free. It has all of the references, it has all of the science. So feel free to get that because then you'll get access to all of this information. You can download that using the link that I'll attach below. Lastly, this is purely for educational purposes. This is not designed to take the place of getting medical care. So let's jump into the science, the link between skeletal muscle and brain health. Over the last 150 or so years, we've seen so much, I guess varied, but so much, at least recently, interest in this idea of building skeletal muscle. Much of this has historically been concentrated in sectors like bodybuilding, sports training, and competitive weightlifting. And only recently has there been this push to understand the pivotal role of skeletal muscle in domains like longevity and lifestyle medicine. One emerging area of compelling research involves this bidirectional relationship between the amount and health of our skeletal muscle and our brain health. It is important to understand that both your brain and your skeletal muscle tend to age more rapidly than other parts of your bodies. What does that mean? Well, loss of skeletal muscle can occur at about 1% per year. And that means by your 80s, you may have lost over half or 50% of your skeletal muscle mass. This decline in the mass and the function of your skeletal muscle, which is called sarcopenia, correlates with several brain-related issues. In a 2024 meta-analysis, sarcopenia was linked to a 56% increased odd for having mild cognitive decline, or MCI, and a 297% increased risk for having Alzheimer's dementia. In a 2022 systematic review and meta-analysis, sarcopenia was linked to a 57% higher risk for having depression. What about those who don't have overt sarcopenia? So they haven't lost all that muscle mass, all that muscle health. Well, in a 2018 study of over 3,000 men and women, lower skeletal muscle mass was linked to a higher risk for depression in men, but it was not seen in women. But when you look at a much larger analysis of over 160,000 men and women looking at the UK Biobank sample, a lower hand grip strength, which we'll talk about more in a moment because hand grip strength is actually a well-regarded measurement for skeletal muscle strength, was linked to a higher risk for depression and anxiety. When you look at hand grip strength, and I guess just real quick, what we're talking about here is using a meter which you squeeze down and it tells you based on how much force you've applied your hand grip strength, and that correlates with your systemic skeletal muscle health. So looking at this is an important proxy for muscle health. And when you look at hand grip strength in relationship to dementia, a 2022 meta-analysis found that those with the highest hand grip strength had a 42% lower risk for having any dementia, a 32% lower risk for Alzheimer's disease, and a 52% lower risk for vascular dementia. So really compelling data here, basically showing that using hand grip strength as a proxy for muscle strength tells us about our risk for developing dementia. Let's talk now about why muscle actually seems to impact the brain. Beyond these correlations, there are mechanisms that help to explain the important and powerful and sustained effects of having healthy muscle, specifically skeletal muscle, for brain states. A key reconceptualization of the role of skeletal muscle on brain health relates to its metabolic effects. Metabolism is how our bodies produce and use energy to power our cells and sustain our tissues. Skeletal muscle is a key metabolic organ in our bodies for several reasons. First, when we exercise our skeletal muscle, it uses up or it needs a whole lot of this energy currency called adenosine triphosphate or ATP. ATP generally comes from the breakdown of circulating glucose, what we would call blood sugar. And when we exercise our skeletal muscles, they pull more glucose out of our circulatory system because there's increased blood flow and an increased production of glucose transporters that go on top of our skeletal muscle cells. Blood sugar levels matter a lot. They're one of the most important markers of metabolic health, and when they are too high or too low, blood sugar issues are well known to influence our brain state. They correlate with a wide variety of brain issues when, again, they're too high or too low, including impaired brain metabolic rate. And that means that if we can help to keep our blood sugar stable by targeting our skeletal muscle, we can gain metabolic benefits for our brains. Now, let me just say here as a quick aside why this matters so much. So it's not just that people who have metabolic dysfunction are at higher rates for developing brain issues, which they are. But when we look at what seems to happen in the aging brain, it seems less able to or less interested in utilizing glucose. So what we're looking for now is a way to keep our brain's metabolic sensitivity high over the course of our lifespan. So improving peripheral metabolic health is one way that we may be able to improve brain metabolic state. And if we can do that over the course of decades, we may actually be able to decrease the negative effects of metabolic dysfunction on our brains. And those negative states seem to be atrophy of our brains and higher risk for neurodegenerative diseases, and in particular, dementia. So, with that said, exercises that activate our skeletal muscle have been shown to have an immediate and enduring positive effect on blood sugar regulation, as well as an associated metric, which is called insulin sensitivity. This is very important because blood sugar regulation and peripheral insulin sensitivity are metrics that correlate with worse overall brain state. So if we can work on our peripheral metabolism using our skeletal muscles, that is a good thing for our brains. In the context of high energy demand, so sprinting, explosive exercises, things like rowing or high intensity training or weightlifting, skeletal muscle energy use outpaces the oxygen supply in our muscles, and this leads to the generation of lactic acid. Now, lactic acid is something that we've historically thought of as a waste product of muscle metabolism. But interestingly, lactic acid, which kind of interconverts with a molecule called lactate, is important in that lactate is now being recognized as a key energy source and a signaling molecule within our brains. So all of this is to say that one of the key reasons to exercise your skeletal muscles and keep them happy as it relates to your brain health is because healthy, happy skeletal muscle promotes better metabolic health. Better metabolic health promotes better brain health. The second pathway that links skeletal muscle to healthy brain function is immunity. In addition to the well-recognized effects on metabolism, skeletal muscle is understood to regulate the immune system. Of the 300 plus different molecules produced by skeletal muscle, these are actually called myokines. Many of these molecules are overt immune signaling molecules like interleukin 6, interleukin 7, and interleukin 15. These are molecules produced by our muscle that are directly influencing the immune system. Brain health is significantly and consistently affected by the immune system, and in particular, an alteration in the immune system, which is called inflammation, specifically chronic inflammation. So if our muscle can regulate the immune system, and the immune system in the body translates into changes in the immune system in the brain, then production of these molecules from our muscle through exercise is a direct pathway that links our muscle health with our brain health. The effects of resistance training on whole body immunity and inflammation are multiple. In general, weighted exercise seems to decrease total body inflammation. This is a good thing for the brain because inflammation in the body, what we would call systemic inflammation, is correlated with a host of brain dysfunctional states. New research also suggests that the immune active myokines produced by our muscles may play a central role in regulation of our overall immune system and may decrease our risk of progressing towards an unhealthy state of immunity called immunosenescence. That is a technical term that basically means aging of the immune system. And this aging of the immune system, again, immunosenescence, is correlated with worse overall health and with more premature aging of our entire body and our brain. In addition, the effects of exercising on our muscles may be different depending on our age and sex, as was demonstrated in a 2024 study. Again, that link will be in this muscle guide, which you can download and get access to all of this research. The third pathway that we'll talk about that links muscle health with brain health is so fascinating. It's neuroplasticity. Now, neuroplasticity is, again, our brain's ability to rewire itself with each moment of each day. And muscle seems to have a specific effect on this rewiring process. So neuroplasticity is thought to be a key driver behind mental and cognitive health conditions, and it's also seen as a pathway that may be a way that we can positively influence brain health if we can activate healthy neuroplasticity. Problems with neuroplasticity are believed to even contribute to shrinkage of the brain. So if we can improve neuroplasticity, we may be able to grow new brain cells and create more connections between our neurons to offset the atrophy that tends to happen with aging. Multiple studies now confirm that resistance training may have a direct and positive effect on neuroplasticity-related brain pathways, helping us wire our brains for health. Among the many molecules produced by exercising skeletal muscle, as I had mentioned, this is called the myokine subset of molecules. One subset are believed to increase healthy neuroplasticity. And the most commonly described molecule in this set is called brain-derived neurotrophic factor, or BDNF. It's well known that levels of BDNF in our blood rise after both aerobic and resistance training, and lower levels of BDNF in our blood are linked to conditions like depression and dementia. But it's important to note it's not all about BDNF. Other molecules made in our blood or made that are produced by our muscle put into our blood during resistance training, like cathepsin B and irisin, may move through the blood-brain barrier and increase BDNF in the brain. These pathways may explain why early data shows that people who regularly engage in resistance training may be protected against brain atrophy. So again, three core pathways that link muscle health with brain health. We talk about metabolism, immunity, and neuroplasticity. How do we actually take advantage of this? What do we do to build healthy muscle to support a healthy brain? Let's talk about some practical strategies. Strategy one for building healthy muscles is so straightforward. It is to exercise those muscles by lifting heavy things. One of the best things we can do to keep up skeletal muscle mass and health is to use our skeletal muscles regularly. And one of the best ways to ensure we're preventing sarcopenia and promoting excellent muscle health as we age is to engage in resistance training. Resistance training basically means pushing or pulling against weight, so weight training. There's lots of data to support this. In one study with people with existing sarcopenia, this was a meta-analysis showing benefits to leg strength and hand grip strength from doing resistance training. In an umbrella review from 2024, looking at healthy adults, resistance training was found to improve muscle mass, strength, and physical function compared to those who did not exercise. And key strategies to benefit from resistance training include the following. One is to prioritize progressive overload. Basically, this just means gradually increasing the weight, the reps, or the intensity of your workouts over time. This helps challenge your muscles to help make them grow stronger. Some people really like tracking their workouts to make sure that they're continuously upgrading their workout. But the basic idea here is just to ensure that you're keeping your muscles progressively at the edge of the correct amount of strength. This doesn't mean that you want to injure yourself. This certainly doesn't mean putting a ton of weight on the bench press or the squat rack so you can max out, so that you can prove to yourself you can do a certain amount of weight. What we're just talking about here is putting some progressive overload on your muscles. Definitely want to make sure that you're overall augmenting those days of progressive overload with rest so that you're able to let your muscles recover so you can build up more strength. Step two would be to focus on form and technique. Now, this is something that when I was younger, I really didn't seem to care too much about. And one of the things that I've learned as time has gone on is there is so much importance to doing exercises correct, because if you do not, then you wind up injuring yourself and you wind up not being able to exercise for months at a time. So if you're somebody who doesn't really do much weight training or resistance training, start with lighter weights, start with body weight exercises. If you don't do any of this exercise at all, I think working with a trainer for at least the first couple of sessions is a great way to make sure that you're at lower likelihood of injuring yourself. And then three would be to maintain a balanced routine. And ensure that as you're using these resistance training exercises, you're not neglecting your lower body. Why do I say that? It's because the majority or the largest muscles in your body in terms of skeletal muscle mass are actually located in the bottom of your body. So things like your leg muscles. It's a great idea to, of course, hit all the muscles you can, but if you're going to be prioritizing muscles, make sure you do compound exercises if you can, because then you're going to get multiple muscles at the same time. So the coming back to the point I made before, obviously great if you can do arms and legs and chest, but if you have to pick some muscles that are most going to be responsible for getting some of these benefits, remember the majority of your skeletal muscle is in your lower extremities. So do not skip leg day if you're going to the gym. Some practical considerations here would be you're obviously not, well, I shouldn't say obviously, but most people don't have time to spend hours a day in the gym. But if you are going to be making a lifestyle change to incorporate resistance training, shoot for about 2 to 4 resistance trainings each week. And that way you can maybe get some of the major benefit of this without having some sort of an overload and not being able to sustainably continue these exercises. As we look at part 2 of this, so we talked about the exercise, let's focus on the nutrition because obviously it is incredibly important as you're tearing up these and breaking down these muscles to replace and repair and rebuild your muscles. So muscle health benefits most when you couple exercise with good nutrition. And of course, this gets us to the topic of protein. When you build and repair your muscles, you need access to amino acids that are present in dietary protein. And generally speaking, research supports the use of multiple forms of protein for protecting and enhancing muscle health. But there is some data, and I will just put caveat on this. This is not some sort of a conclusive data set, but there is some good data for things like whey, soy, and casein proteins. Usually they are sold in isolate form, so this would be something like a supplemental protein powder as opposed to just consuming them in milk or in forms that are found in food. Why is this? Well, there's some data to support that they have a more significant effect on muscle synthesis, although the effects of whey are probably the best characterized. Partially, this is just because more research has been done on these protein isolates and not necessarily that they are absolutely the best, but rather they've been best characterized. In a 2024 meta-analysis of people with sarcopenia, researchers found that whey protein did lead to significant increases in skeletal muscle mass. And in another 2024 review, they found that resistance training plus protein significantly increased muscle mass and muscle strength. There was one interesting kind of corollary to this, which was a recent large-scale analysis of protein supplementation in adults found that while protein supplements improved muscle mass independent of exercise, it didn't seem like there was a certain type of protein timing for the day, meaning do it in the morning, do it before or after exercise, that mattered that much. So that's actually been substantiated in other research, and I think that it's an important thing to consider, which is if you are going to be trying to build healthy muscle, some people say you absolutely need the protein powder right before, right after the gym, but the data don't necessarily show that that is as important as we think. The general consensus as we're talking about protein, and here we're again mostly talking about supplemental protein, not protein in diet, which we'll talk about in a moment, is that insufficient protein intake contributes to sarcopenia, and you do want to make sure you're getting adequate protein each day. For those who are exercising, many still are recommending timing the protein around before or after the workout, but honestly, that might just be so you don't forget to take the protein powder and be less about the actual benefit you get from dosing it right before or after. There are probably many people with differing opinions on this. I'm just stating what the research seems to find as of now. When it comes to the debate over the source of the protein, the dose of the protein, we'll talk about each of these in a moment, but when it comes to this debate, there are very strong opinions on either side. There's an active conversation around whether it should be animal-based protein or plant-based protein. Animal and plant-based proteins do differ in terms of the amino acid availability, digestibility, other nutrients that accompany the amino acids in protein, especially when they're coming in a food-based source. Some considerations here include the fact that animal-based protein sources tend to have a more complete set of amino acids and higher levels of muscle-building amino acids, leucine being a good example. We know that leucine tends to be reduced in the blood of men and women with sarcopenia, and again, higher levels in animal-based foods. Some recent analyses show signals for animal protein in increasing percentage but not total muscle mass in young adults, but there was a study that was published in 2023, which was an interventional study using advanced muscle imaging showing no difference in strength or muscle growth in young adults. from those who took a animal, or I should say a milk-based protein source versus a plant or a mushroom-based protein source. Some data do support an advantage to prioritizing animal-based protein sources for things like mental health, but some large-scale observational data show that plant-based protein sources may beat out animal-based sources when it comes to better mental status. So what do we do with all of this information? I've kind of said things on both sides of the equation. Mechanistically, animal protein wins in several categories, but practically speaking, if you're going to be supplementing protein powder, plant-based protein, animal-based protein, probably not a huge difference as long as you're getting enough of the grams of protein per day to make sure that you're getting the anabolic effects and the amino acids to build healthy muscles. Let's now talk about some ideas around the actual amount of protein intake. So ideally, I'm a huge fan of getting whatever your body needs through food as opposed to through supplementation, and that includes supplemental protein. But this isn't always feasible. Let's talk about minimums here. So again, there's a huge debate here over how much protein a person needs, but generally the consensus is that the minimum is 0.8 grams of protein per kilogram of body weight for the average adult, and that translates to 0.36 grams per pound. This can come from animal, plant, or maybe best, a combination of both sources. Who should consider consuming more protein? Those over age 65, those who are more active, those who are trying to build muscle. And then you go up 1.2 to maybe even 2 grams per kilogram starts to make sense. I know that there are those out there who advocate for very high doses of protein, even up to 2 grams per pound. These things can become incredibly cumbersome. And can become very challenging to basically incorporate into your day-to-day. What I would say is I have not seen any good data suggesting that very high levels of protein intake, at least at a meta-analysis level, is going to provide that much of a significant benefit. And I think, again, you get to the levels of extreme diets where you start consuming hundreds and hundreds of grams of protein per day, and it can create sustainability concerns. And also you may not be getting the other nutrients which you need because you're spending your entire day trying to consume enough protein. Ideally here, you're talking with a nutrition expert or a healthcare provider about your personal goals. But if you are looking to supplement with dietary protein, as I said before, there's tons of data around whey protein. I should say, interestingly enough, whey protein is one of those proteins that has been associated with more of a kind of anabolic effect on molecules like insulin, like growth factor 1. So one consideration would be for people who have conditions associated with higher levels of IGF-1, for example, acne, whey protein may not be ideal. But in terms of cost and in terms of efficacy for muscle growth, whey protein has been probably the most highly studied protein. That's in terms of a supplemental protein. But many other protein sources are great. So if you're a vegan or a vegetarian, plant-based proteins can be absolutely wonderful and provide an effective source of protein. Let's move on now from general nutrition and talk about supplements for muscle health. So there are many supplements on the market. Some of them have efficacy, some of them don't. We'll talk about some of them with the best evidence, starting with omega-3 fatty acids. Omega-3 fatty acids, commonly called omega-3s, are polyunsaturated fatty acids. They're found in plant and animal foods. They influence immune, metabolic, and even neuroplastic pathways. They're generally consumed in supplemental form if we're looking at some of the higher doses. And recent research suggests that the omega-3, in particular EPA and DHA, which are those that are found more in kind of aquatic or marine-based sources, may support lower body strength and functionality in older adults, even if they don't grow muscle. So that's really interesting. It's not necessarily that you're going to take omegas or eat more omega-3 foods and grow muscle, but rather that it will support muscle health. Typical dosing, you're looking for around 500 milligrams to 2 grams a day of combined DHA and EPA. The next one we'll talk about here is beta-hydroxy beta-methylbutyrate, or HMB. HMB has been studied in a number of recent publications, and recent data suggests that it may benefit grip strength in people with sarcopenia. HMB is a breakdown product of the amino acid leucine. At the studied levels, which has been shown in these studies to be beneficial, it's usually a supplemental form as opposed to something we get from diet. Next up, one of my favorites, creatine. Creatine is an amino acid. It's found in our bodies naturally. It's also coming to us from diet. Creatine is stored in our cells as phosphocreatine and free creatine, and it produces energy in our muscles and brain. Supplementing with creatine may increase muscle mass, especially in those engaging in resistance training. It's also known to increase muscle strength in older adults and has been linked to better brain health. So it's linked something for which for a number of reasons, I think is a worthwhile consideration. Most research as it relates to muscle health talks about 3 to 5 grams a day, but we've recently seen data in human trials for brain health looking at higher doses, so 10 to 20 grams a day. Again, for the purposes here of the muscle to brain connection, I think about 5 grams a day is what the research would most strongly indicate may be beneficial. You should always speak with your practitioner to try to find a dose of anything, whether that's a supplement or a drug that works best for you. So let's tie all of this together. The bottom line, what I'm trying to emphasize here is that muscle health is an empowering and an amazing tool that can help you to improve your brain health today and for the rest of your life. Your muscle is directly tethered to the health of your brain. And by building and maintaining healthy muscles, you can unlock an incredible cascade of benefits for your brain and overall health. Pathways include metabolism, immunity, and neuroplasticity. And there's so many individual strategies that you can get to, whether it's optimizing your protein intake, supplementation, exercises. This is why I think if you're getting started with this, if you've never done this before, working with your healthcare provider and a personal trainer to get started can be an amazing tool. But the bottom line here is that healthy muscles are an incredible pathway towards healthy brains. So starting that first step today, to getting involved with more resistance training, to getting involved with more nutrition to support healthy muscles, I think are awesome tools to support your brain. If any of this has been interesting to you and you want to learn more about your brain and how to optimize it, make sure to subscribe to this. It's incredibly helpful to me. Let me know in the comments what was most interesting. And again, all of this, including all the references, is in my free muscle guide, which you can download clicking the link at the bottom of this video or at the bottom of this podcast. Thank you so much for watching. My name is Dr. Austin Perlmutter. I'll talk to you again soon.